Welcome to the Todd and Noah show, taking the mystery out of electric motors.
No more mystery. No more mystery.
No more mystery. If you've been listening to our podcasts, you should know that there is nothing mysterious about an electric motor. Don't be afraid of these things.
Right.
They don't bite.
We've been taking the mystery out for a while.
We've been trying to get the mystery out of this motor for a long period of time. Hopefully we're helping. We did get, I will say this, there was a post on LinkedIn where some individual had put, I think they were on, it may have been a Mobius Connect site, where he said, all you have to do if you want to learn about electric motors is listen to the Todd and Noah Show podcast, and that was it.
Obviously, he knew what was going on.
I took that home, and I showed it to my wife, and I said, I'm not doing the garbage anymore. I'm a movie star now.
Listen, the most respect I ever got from my children when they realized we had a real podcast.
It's so funny.
It's unbelievable.
Yeah, when you tell people, we do YouTubes all the time, they do, what? Really? You?
That's right.
You do YouTubes? You do podcasting? Anyways,
it's supposed to be fishing, not podcasting.
It's supposed to be fishing. Anyways, Noah, this is our second, the case studies from the field, a forensic review.
Right.
This theme kind of gets around understanding process knowledge, understanding the system knowledge is so key, can really help you when you're trying to diagnose motor issues. And the first one we're going to start off with is, once again, where you can collect every inrush with a PDMAI. So our first case study comes to us from PDMAI.
Absolutely. And, right after you hear me say, hello from sunny Tampa, Florida, you usually hear me say, inrush is my favorite test.
Yeah.
And this is one of them. And so this was what a great application. And this is a situation where, remember back when we were first coming up with the fault zones, we got the power quality, power circuit, insulation stator, rotor air gap. Say that very fast because I say it a lot.
It's a tremendous protocol because it really makes it digestible. And I always try to tell when I'm out doing a workshop, wherever in the U.S. or out of the country, we always try to say, make it digestible, make it easy to communicate and easy to. I remember when I first came working at PDMA, you said, well, the motor's broke. Or is it easier to say, listen, according to IEEE 43, 2015, it meets the insulation resistance requirements. According to IEEE 519, there's no harmonics, in the system, so that's check. According to IEEE blah, 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 there's no resistive imbalance. When you can put them in that type of category, one, you immediately become
more believable.
The expert.
Absolutely. And that's important, especially if you're assisting someone in making a decision. And even back then, I remember thinking we should have a seventh fault zone.
Seventh fault zone. Listen, it took me 20 years to learn the sixth.
So the seventh fault zone, you'll appreciate this as an electrical type. The seventh fault zone was going to be, it's not the motor.
Okay.
And it's still true today. I can tell you that there's a general rule of thumb that if a system has a problem, any system, and there's an electrical cable within 15 feet, must be the motor.
Yeah,
it's got to be an electrical problem.
I mean, that's the truth.
It was on our submarine. That's how we operated. So basically, we had to go prove whether it was electrical or not before anything else would happen. So the beauty of this case study, this forensics that we're going into, is it would qualify for fault zone number 7. It's not the motor.
Right. It's not the motor. And in this case here, as we talk about this case study, with the eye, you said you collect every inrush.
Yeah, so the PDMAI,
so you have a running
technology,
history of all the
catch
startups.
Everyone.
And then all of a sudden, in this case study, what generated this case study was problem. We have an elongated startup.
Right. We were seeing 5 seconds day after day after day. 5-second startups. Now we're talking about the time that the button is pushed and there's a peak inrush current to the time it reaches steady state. All right. 5 seconds every day.
Like clockwork.
Like clockwork. Then all of a sudden we get an alert. 15 seconds.
So you got an alert.
We did.
So when something exceeds the band, you automatically get an alert to your cell phone.
That's the idea behind permanently installed technology. Absolutely.
That's key.
Got to get an alert. And the nice thing is, from 1,000 miles away, we can confirm it. That's big.
That is huge.
And by we mean you, the listener.
That's right. If you have it installed. Exactly.
We always say the PDMI has an eye on your motor 24 hours a day, and it's your eye, right?
Yeah.
Not our eye, right? We're leaving at 5 to go home, right? But that eye works 24 hours.
But we're helping you keep an extra eye.
Absolutely.
On the asset. Right. So consistently, motor starts up, takes 5 seconds every day. Now it doesn't. You get an alert. What's next?
So the very next thing is to start looking at certain things.
Yeah.
Remember we talked about in different countries and even in this country that if the voltage drops, it can create a problem, right? Is it possible that a rotor defect, right? We talked about in our tips of the weeks and different things. If a rotor defect can create a longer startup, we have to be concerned about that. So as we go through, when we look at the voltage, we look at the current, we look at the load, what we quickly realize here is that the startup current that's driving this thing into operation was the exact same level as it's always been. It just took 3 times longer. So we know that if the startup current is the same as it's always been, but it takes longer, now we go to machine train. It's not electrical.
So in this case here, we say machine train. So what's the next step? We go to the operator, right?
Call the company.
We call
Absolutely.
the what would we call that? We call the end user.
Yes. In this situation, it was part of a beta testing scenario. So, we were still remotely involved quite heavily. And so as soon as we got the alert, verified it was not electrical, we contacted the on-site person and said, hey, we've got a problem here. Yes, we've got a 3-time start. And they were able to go to operations, talk to them, figure out what was going on.
Or I think what really happened also is they were aware of the system.
They knew
exactly when you called. I think they said, "Oh, well, we didn't clean out the extruder properly, or we didn't do proper cleanup."
Right. So basically, these are refiners. These are a grinding type scenario, and standard operating procedure is that if it's going to be shut down for any period of time, you need to clean it out because it'll harden. The material will harden and cause a real long, real excessive startup. So obviously that didn't happen. So in this situation, that didn't occur, and as a result, we had a 15+ second startup. Now you heard me in previous tips or previous podcasts talk about 3,000 starts, for a motor's life expectancy. Well, when you triple the startup time and triple the stress on the rotor and the rest of the circuit, the question is, how many starts do you give that?
Right, because it's designed for 5 seconds, or for the most part, if it took 5 seconds to start it up, but when you hold that additional current,
eventually it would have tripped. And that's what we don't know. The mistake, to admit a little bit of a mistake here, we had a 15-second, inrush setting, and it went beyond our setting. Now, if you do that long enough, the machine will trip to protect the rotor. Most people don't realize that long-term trip, the delayed trip that occurs, it actually prevents the rotor from burning up.
Yeah.
And because there's so much current flowing through the rotor at the time.
Right. And so we would recommend, if we would have recommended to the end user, maybe let's go out and do a offline test.
Absolutely.
Let's see if it has any type of, let's see if anything shows up in the standard test. Let's do a polarization index test on it. Let's do a rotor influence check. Let's verify that everything is correct. Now, this is great because we saw, and now this would be highlighted in the historian as a potential issue.
Right. In fact, it's an elevated peak where you normally have 5, 5, 5, 5. You've got a 15-second peak as a one-time start indicator. Yeah. That's huge, and that's there for 5 years. And again, it's just such a nice tool to know, to look at that, know immediately that it's not electrical, and then to get to the root cause. And not always do we get that root cause, but this was a nice one.
No, and this, like you said, you didn't have to be there to see it.
Right.
It's automatically installed. You turn the motor on. You get input on it. We find out that through just a little bit of corrective action, saying, okay, when we do the clean out, when we do the changeover, whatever it is,
right,
let's make sure that we do a proper cleanup. This is the end result. It extended maybe this motor now has a failure built into it
Maybe
because
a
we
reduced life
exceeded
expectancy.
it.
Absolutely.
Maybe it's reduced now.
It would certainly be wise to look at what the normal procedure is for bringing in the washdown. Like, is it 15 minutes? Is it 30 minutes? What is that? It's not hard to look at our historian, which is a time series plot, and say, hey, there was 2 hours between the off and the on time period. I'm sure every site has their own procedure on the washdown. When should it occur? Nothing wrong with using the inrush values as an indicator as to what's too much.
So this next case study is just another case study where the individual is very familiar with the plant processes, applications, what happens when you come off of an extended shutdown, what could happen if you are 2 weeks into a running period and then you shut down. What can happen after it rains with resistance to ground measurements on specific assets that may not be protected from the exterior environment or the weather. But in this case here, it's a circular circ water pump that the individual does know what happens. And it's a 4,000 volt, 355 RPM, so it's a slow rolling motor.
Really slow.
196 bars, so it's big. It's huge. And as a result, this is the individual who takes an inrush for process all the time.
Right.
Regardless if it's running or not. And when he took it in November, he saw that it was very even.
Steady state. This is a centrifugal pump. It's pulling water out of the river, whatever, for cooling purposes. It's when you're measuring the current, the RMS envelope of a centrifugal pump, you expect it to be pretty steady Eddie. Not a lot of variation.
Yeah. So then he comes back and does a routine testing, does the same thing, gets power and out, does an inrush startup, and he sees massive current swings, 200 amp current swings.
Yeah, it's
but are
almost
not consistent.
No, and on a centrifugal pump, so it's almost like it unloads and then reloads, it unloads and it reloads, and unloads.
Kind of like on
reloads.
a rotor. It almost looks like a consistency when it's a rotor issue.
Yes,
this
erratic would be a good description. Yes,
for this very erratic, like 200 amps here, big swing, and then maybe not such a big swing, and big swing again, maybe not such a big swing. But because he had knowledge, because he was very familiar with his application, he knew that when you secured both circ water pumps, that debris would tend to settle. And then on startup, that debris might get all pushed into the 10-foot filter system that they had. And if it did that, that would create those current swings.
Absolutely. Between that or the manatees, hanging out down there, who knows?
Let's not scare the little children out there with a manatee
that's what the
getting
screens are for. They keep them out.
up into a filter stream. I would hope that that's not what we're having to clean out of there. Hopefully, it's just debris, dirt, planks, or whatever, algae.
Yeah,
whatever it could be anything.
Could be a shark getting a back scratch on the inlet screen.
Just to be advised, there were no manatees hurt during this podcast. We have nothing to do here. No manatees were ever harmed during this podcast. On
a technical nature of the screen, the question is, why would a dirty screen create such an RMS envelope, right? Well,
right.
What one of the things we worried about in a submarine, right? A little bit of a sea story. When you're underwater, and
for those of you who didn't know, Noah was actually on a submarine. He was on a boomer, which essentially was 3 months out and 3 months in.
That's right. I wasn't a boomer on a boomer. I was a Gen X on a boomer.
You were a Gen X on a boomer. Well, thank you for that clarification.
I want to make sure everybody's aware.
Yeah, they don't want to confuse you as a boomer. That's like a dad joke.
It's a boomer squared.
That's a really bad dad joke. Don't let your kids know you do a podcast. They will think, oh my God, Dad, you are so square. Anyways,
so we're underwater and we're sleeking through, sneaking around. And if as a throttleman you decided to open up the steam, right, and then pour steam onto the turbines and start whipping the screw to push it through the water, right? If you do that excessively, you'll draw air bubbles. It's called cavitation. Everybody knows what that is, but that's a big no-no if you're hiding from from the bad guys, right? So it's the same thing that this condensate pump is experiencing, right? For whatever reason, with the debris and everything blocking the flow of water into the pump, it creates a low pressure environment and bubbles are formed, cavitation is formed. All of a sudden, it makes the motor appear like it's unloading and reloading and unloading and reloading. So great use of the tool to identify a natural, water pressure situation.
Yeah. On a personal note, I have 2 dogs, a Malinois and a Shepherd, that go in my pool daily, and they displace all of their hair in my filter system. So I know firsthand
the effects.
And I used to have pebbles in my backyard, and they would flick them up in their little paws, and then it would get sucked into the pump itself and disrupt everything in that system. So
it's a product of cavitation.
Personal note, I know the pain in which this individual is going through.
That's right.
So that was understanding the knowledge, right? So understanding why, what the system does, what's the normal routine after a shutdown, what can you do? This next one is, I like to call it almost like a growth story. In an ability, remember we said in one of our earlier, I think it was our tips podcast, where we had said, you have to crawl before you can walk,
right?
And before you can run, you have to walk pretty cleanly, and then when you can run, you can really understand the knowledge of the tester. But this is where an individual who started to take data, but wasn't maybe sure exactly of what it was that we were collecting,
right,
and what it all meant. So in April of 2015, he takes a demodulation test just for identifying speed. You can also use it to identify mechanical anomalies. Like we use it for speed, and we also use it for mechanical anomalies.
Vane
correct?
pass, blade pass, gear,
belt frequencies. You got to know some things,
right? You
have to know some things. Right. But here, it takes him till September of 2016. After he attends a lunch and learn or a corporate reliability get-together where somebody sat up and said, you know what, before every motor test, I usually check an inrush for process analysis. So he wasn't doing that. Then come 2016, after you come back from
apply what you learn.
Yeah, after you come back from a trade show, everybody's like geared
excited,
up, ready to go.
Save the world.
Save the world. If not the world, at least the plant.
That's right.
They'll take that.
Absolutely.
You don't have to be so aggressive and save the world, but you can certainly help save the plant. He starts to take his first inrush, and he sees a huge current swing.
That is big.
Unbeknownst to him, he was unaware that this was happening. A 30-amp swing and a huge change in load variance. So that's meaning that the load is coming on and off, correct?
Generally. Yeah, either the load or some anomaly.
Yeah. So he establishes band alarms around that demodulation screen. All the peaks that were in there, he puts band alarms in there. So he comes to find out the gearbox was removed from service and sent to the shop, where shop personnel disassembled gearbox. According to the engineers, they determined that there was a slight misalignment causing the motor to load and unload. Well, we saw that in our load, the loading changes, load variance.
Absolutely. And then speaking of the load variation, it's a demodulated extraction. So we run the mathematics off of a demodulation test. The nice thing is, by removing line frequency, it's effectively a direct relationship to torque, right? So when you talk about a load variance of, ranging from 2% to 9%, there's really no reason on a pump for torque to be changed, or a fan to be, torque to be changing that much. That's a shocking number.
So the thing about this case study that was very intriguing and very interesting to us was that first he started, after maybe a year or two of doing the data, to do inrush startup as a process analysis tool. But this gearbox was changed in that time. But he had no knowledge that the gearbox had changed because it was done on an off shift. So if he wasn't there, he had no idea. Had he known that the gearbox had been changed, what's the first thing you want to do? Probably go take a test, right?
Re-baseline.
Yeah.
Absolutely.
Get a new baseline. So we had no real understanding. So we always come back and say, lessons learned type of thing. Learn the process that is being tested. Is my motor connected to a fan, a belt, a pump, compressor? Open your lines of communication between the reliability and the technicians or different
electrical over to mechanical. A lot of times your vibration
exactly.
team, in this situation, we're not necessarily tracking gear mesh, which is a vibration centric kind of number, but we are very closely tracking the secondary shaft frequency, third shaft frequency. So, by speaking, although we're going to see the peak, you can do some calculations, you can figure out the gear mesh. It's a lot easier to just reach across the hall and say, hey, what's the gear mesh frequency? Do some calculation. You know what the secondary shaft frequency is. Now you got a band alarm. Now you can track that. So absolutely.
So another thing is you can call PDMA if you're not familiar with the data. That's always going to be a resource that you can tap into. And we're here for you to answer any of those questions. But this was a nice case study because it really showed the growth of the individual.
Absolutely.
Of how they took how they were able to go from one area of utilization of the technology to really opening up. It's like you could have a Yugo or a Ferrari. You make the decision. If you want to use all the bells and whistles, you've got yourself a Ferrari.
Yeah, and these gear-related frequencies, just for the listener, we're talking to drop 75%, the significant drop in the gear-related frequencies that we were trending. So definitely an ideal use of the technology.
Yeah, so now here we go again. Here's another circ water pump. Now this pump is in the river, and it's sucking water out, just like that first time it was in the circ water pump.
Right.
So you're not going to be able to see the asset unless you get a diver.
If you're diving, maybe. Even then, sometimes this water is pretty murky.
Yeah, right. It could be muddy.
You might see a big flathead catfish that scares you out of the water. That's
something like that. I don't. Well, if you're on Naked Afraid, you want to see catfish because then you kill them and you want to eat them. Depends on your situation.
They should say eaten in a few Naked, days. Afraid, and Hungry. Yeah, that's what I would call it.
So once again, this individual does in-rush startup testing. He sees everything's clean. Demodulation, everything's clean. Overall noise levels are very good. But in 2010, we get a huge increase. Something changes. But because you have a baseline, you can look back at that and say, "Whoa, what's changed?"
It's huge.
Whoa,
it's such a big difference. And you talk to our tech support guys. Nothing's worse than opening up a history chart that someone sends us.
One test.
And there's one test. It just makes it so hard.
It makes it does make it more complicated to be definitive in our answer.
Right.
We can hypothetically say a lot of things.
Right. We can listen to the story, listen to the case study. These guys in tech support, not only do they go out and do the training, they travel and they've done troubleshooting. It's, they're very knowledgeable. Their field experience is quite high, so they're going to provide some good, valuable information, but nothing like a trend.
If you want to be definitive in your answer, having more data longer term is so much easier to come off of. So we see this high noise level, the rotary evaluation spectrum, you can't even tell if it has pole pass high bands because it's pushed up into the observed lines.
Right. This is a big deal. Like a lot of times when someone will send us a rotary eval test. Now, again, a rotary eval test is a spectrum of a current signature. It's an FFT spectrum. And we like to see these FFT spectrums with a low noise platform. And the importance, like you just mentioned, if it gets too high, it actually hides things. Well, why would the noise platform be high? It could be that they selected the wrong current probe and they're only operating within 10% of the normal range, and that gets very noisy. But it also could be, in this situation, load fluctuations that create such what we call it a bin explosion or a broadband of energy being plugged in. If you think of an FFT, it's like a bunch of little bins, and we'll sample the frequency and throw it in a bin. Obviously, 60 hertz, 50 hertz dominate. So that's the largest peak. But if you've got a frequency that is generated and it's very broadband, you start to fill a whole bunch of bins up and the noise level just rises effectively. So with that, it becomes hard to diagnose problems. And we see this on this case study and immediately makes us wonder, what's going on, because it was clean before and now it's not. There's nothing definitive. It's just an elevated noise level that makes us wonder who's doing the test. Did you change something or did something change?
Yeah. So in this case, we don't see any pull pass sidebands coming out. We didn't do a complete inrush, but we know it's not. So normally when we do an inrush and it's rotor related, that it's a very consistent, almost like you can almost audibly hear a rotor problem, right?
If you were close to the motor, you could. Yeah, once it starts, it's a wah, 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 wah.
Right. Like put a baby to sleep type of sound.
Yeah, that would work.
That would work.
Yes.
So they said, maybe it's not the actual motor. Could it be mechanical or the pump? Well, lo and behold, the inlet to the pump had half of it torn off almost. That would create a disruption, would it not?
It absolutely would. So as water is being pulled into the inlet of this pump, it's going to create non-laminar flow, you might say, disrupted flow. And anytime you have differential, pressure, again, it falls back to this cavitation situation where you're now having, pressure issues and where part of the pump seems to be going fine, the other is not. And as a result, you've got airflow, which drops the load. A fan or a pump, most people think if you deadhead it, right, it's going to be a max load. It's not. It's no load, right? So if you stop moving water across the veins of the pump, load drops, right? So if it's trying to move air, not water, it drops. And that's what's going on here. Not necessarily pure air, but non-laminar flow, so the water
There's air
pressure.
bubbles in there.
Air bubbles actually form inside the water itself. For those who are listening to us, if you think about this inlet, literally almost half of the inlet bell is cracked off this thing. You start to wonder, how does that happen to this, ginormous steel inlet plenum? Did it drop? Was it weak? Was there a big shark in that river that we need to warn the locals about? Because that's a big bite, I can just say.
What is that? What's that show?
This could make Shark Week.
Well, it could make Shark Week, yeah. Isn't it the Meg or something? The Meg?
Meg. Yeah.
That's the one you got to worry about.
Yeah, this is...
I mean, those are the ones that come at you while you're in a shopping mall or something. Shark Week, you kind of know where they're at.
Are you
they're
thinking
in the
Sharknado?
Sharknado. That's true. Could be Sharknado. Yeah, those things, they out of nowhere.
They're flying at you.
You're just do. Lion shark. A Wayback Machine, SNL, land shark.
What's interesting about this is how effective current and voltage are at seeing this kind of machine train anomaly.
You don't have to send a diver in. Or if you do send a diver into the water, it's to confirm, not to research.
Exactly.
It's really to confirm that there's nothing going on there, or that's where the issue's at. So you have enough data in your tool belt to say, listen, it has strong current anomalies that are not related to the rotor bar. It has no pull pass sidebands. It has no fifth harmonic. It has no elongated inrush startup. It's just strictly, like you said, cavitation, laminar boundary issues, whatever it ends up being.
And the beauty of technology is without it, they would have looked at the current meter and saw this fluctuation and very likely would have just leaned to an electrical. Hey, what's the easy thing? Not pulling a pump out of the river. The easy thing is to replace the motor.
Yeah.
When it would have done no good at all. This happens way too often.
Yeah. So we'll get to our last one here for the review of a case study or the case studies from the field, or a forensic review of knowing your system knowledge. And this one here is the same one, completed the initial installation of our MTAP 2, February of 2022.
MTAP 2 is a big deal. Before MTAP 2, before NFPA 70E and the whole,
necessary.
It was necessary. It's, we're opening up cabinets in our day and hooking up with the right PPE, of course, you hope. But the ability
rope tied to you.
Absolutely. Rope
one
tied.
Hand only.
Hope the guy likes you.
Only, keep the glove on one hand, work with the other hand.
That was the whole strategy. And now with test access panels, you don't have to open up anything. You can install the test access panel and just walk up with portable technology, hook up, take the test data with no PP at all.
Definitely makes things a lot safer. And the goal is to get you back to your family, right? That's the whole goal. Don't want any injuries out in the field. That's not what we're trying to. There is a risk, but we try to minimize that risk. So we install the MTAP and we start to see swings in amperage and vibration. Did we
Sounds
install
familiar.
the end tap wrong? That's probably
Well,
your
it does happen, but it usually doesn't
First
cause swings in current.
Right.
So yeah, good call though.
Yeah. So the first current signature analysis doesn't really show any pole pass sidebands, and current looks very steady. Then in September, just a lot of noise in the signal again.
Right. And we're looking here at the demodulated spectrum, right? Again, we're talking major elevated noise platform, similar to what we've been talking about in the last 10 minutes.
Yeah. So once again, understanding your system knowledge, they did current steady, the elevated MCSA test, motor current signature analysis test, is up in the observe caution area. Excessive current swings now. So now we're seeing current swings in it that are not consistent.
And can we give a shout out to, if you're overseeing a reliability effort, and this is a perfect example, what if they started, the first test they ever ran was the elevated noise test?
Yeah.
Would they think that's normal? Because I guarantee if they called PDMA tech support, we're going to say, hey, what CTs are you in? Check your connections. What is the current? Do we misdiagnose the CT to put in there? We're thinking it's a bad signal.
Yeah.
But when we had a baseline, guess what we didn't ever guess? We never questioned the installation. We never questioned the CT selection. Can I say that, if you're going to get into reliability, get that baseline. You got to get a baseline when things are good and healthy.
And here's what's a little bit unique about this one is they sent it. They sent the motor to a repair shop.
The initial diagnosis was they think there's a pump problem.
Or the pump. Exactly.
It was a pump. Yeah, they thought it was a pump problem.
They sent the pump. They said, well, pump is bad.
Yes.
But guess what? Pump comes back, and maybe there were some issues. Maybe they
minor. The report was that there was some minor adjustments on the pump, general refurbishment, and sent back and reinstalled.
And guess what? Noise levels are still elevated.
Same thing,
still
different
the same.
day.
Yeah, no real changes. So now this will enhance their system knowledge because they went in and they looked at the pre-filter, and they found a ton of algae, wood planks, a lot of debris got sucked up in there. No manatees.
Yeah, all safe.
All safe.
I heard that there were
little Nemos now. I can't. There may have been some Nemos stuck up in that algae somewhere.
A little bit, just a few.
Little tiny Nemos.
But algae is pretty popular in the Florida waters, and what's not very popular in the Florida inlet plenums are not ladder material, but when you're the
wood planks.
Well, from the when you're building structures to do maintenance on the sides of buildings. Scaffolding debris.
Yeah, no worries. Yeah, I understand completely. Usually you don't find that in there.
Generally not a popular.
Normally not.
It was what a great catch. Did they need the pump overhaul? No. Probably not. And it was probably
not.
But here's the beauty of this is now that they have a before good, during bad, and a post-repair good, the band alarms that they have established are absolutely squared away. Now they know exactly what to look for. So as algae debris becomes excessive, and they'll send divers down to clean that up. And hopefully no more, scaffolding material, but debris nonetheless, it'll be some algae back for sure.
Yeah. And it enhanced their system knowledge. They know now that if they see this type of event on another asset, then maybe they'll first look at the filtering and make sure everything is clear going to the motor or to the pump.
Yeah, flow disruption and cavitation and stuff is a serious deal. All pumps are going to be experiencing it at some point. If they're designed improperly, we're going to see the same thing. It's just nice to have access to see those kind of indications with voltage and current.
So over a year, I mean, we got to the right solution. I'm not sure when PDMA got pulled into this discussion. I don't think it was right away, though. It
was after the pump was pulled.
Yeah.
Yeah, they made the pull. They pulled the pump, did the basic overhaul, and then turned around and realized that didn't solve the problem. Right. So and they did the right thing. Call us. And ideally call us before you call the crane, not after, but call us anyway.
Yeah, call us. And it's just as much a learning experience for us as it is for the end user. So they're smarter now, and we're smarter as well.
Absolutely.
We have more knowledge.
Can't say we'd ever seen the scaffolding algae direct influence, and we have it now on record.
Now we have it on record.
And for those who are quantitative types, our the vein pass energy that was created as a result of the debris. It was pushing up into the 0.2, dB level on the spectrum, and the new baseline has it down. We're talking about 0.02. It's a big difference.
Well, for you quantitative types out there, Noah just satisfied that need for you.
I knew you were out there. There's a few of us.
There's a few out there. Okay, that brings us to the end of this case studies from the field, a forensic review focusing on know your system. That's so valuable. Know your system.
Yeah, and we'll take votes out there as far as should we make a seventh fault zone called "It's Not the Motor."
Yeah, I'll get it under my
yes.
belt. I think the problem is that seventh fault zone is always changing.
That's true.
Depending on what the soup du jour is of the day, what's the most important thing. But the 6 are for sure there, and they're very effective. That brings us to the end of this one. The case studies from the field of forensic review, really understanding your plant and understanding the processes behind it. If you have a case study you'd like to share with us, we'd be more than happy to entertain it, take a look at it, put it together for you, do the audio for you. So that brings us to the end. Hope you enjoyed what you heard today. We appreciate everything that you guys, comments that you bring to us. We enjoy that. And the good ones anyways, not the bad ones. You can keep those to yourselves. But we'll definitely take all your good comments. But anyways, until we talk to you again, you have a great day, and we'll see you real soon.